an ion, we are not going to worry about polarity or IMF. Okay, we'll worry about that later. Okay, so for anything that's an ion here, I am just going to worry about the Lewis dot structure and about the shape, because these charges are going to throw off our polarity. So we're not going to worry about the polarity, and thus we're not going to worry about the IMF for any of these ions. Okay, sulfur is bonding with hydrogen. It's an ion, so I am going to count 6 for sulfur, plus 1 for hydrogen, plus an extra 1, gives me 8 electrons total. Make sure that for ions that you are showing your electrons and then you're verifying your charges so that you get credit. Otherwise, you will not get credit. Okay, so let me write that at the top. No process for ions, but show charge equation work. That's just this guy right here. And show atom charges so that I can see you knew how to place everything. Okay, so make sure that's your credit. If you don't have that, no points on the ions. Sulfur has 6. It's using 1 there, so 1, 2, 3, 4, 5. Okay, and I have 1 extra one, so I'm going to complete my octet. 2, 4, 6, 8 total electrons. Sulfur has 1, 2, 3, 4, 5, 6, 7. So 6 normal minus 7 gives me a -1. So I'm going to put a negative right there with sulfur. I'm going to bracket the whole thing as a negative. So again, Lewis dot structure with everybody happy. Showing our charges, hydrogen here gets a 0. So I know a 0 plus a negative is a negative. I have the brackets to show it's an ion. Okay. I have the equation to show how many total electrons I have. Make sure you have all that for your Lewis dot points. It's only 2 points, or 2 points, 1 sulfur, 1 hydrogen. So this guy is linear, 180 degrees. pH 4 plus. Okay, so I know I'm going to have a phosphorus, and I'm going to have 4 hydrogens going around at all 4 corners. And I know I have a plus. So this phosphorus, 2, 4, 6, 8, he's finished. This hydrogen, 2, he's finished for their octets. And I have 1 less electron. So I'm not going to try to add in or check valences. I'm just going to go phosphorus is a 5 plus 4 hydrogens minus 1, because this guy has a positive. He's lost an electron. So 8 or 9 minus 1 is 8 electrons is what I should have. 2, 4, 6, 8. So even though phosphorus has a valence of 5, he's only going to have 4 valence electrons here. 5 minus 4 is a +1. So he gets the plus, everybody else gets the 0, and that proves that the overall charge is a plus. Okay, this is not sulfate, this is sulfite. Sulfur is still going in the center, oxygens are going around the outside. Gave everybody single bonds. 6 times 1 sulfur plus 6 times 3 oxygen plus 2 more electrons, and that's 26 electrons. So I'm going to single bond everybody, okay, and make everybody happy, and then I'm going to count 8, 16, 24, 25, 26. Okay, and so my number of electrons match what it should be, so I'm going to bracket. And again, remember, some of these ions are not what it exists like in real life, but this is what it exists with your knowledge, so that's what I expect to see. Okay, sulfur, 1, 2, 3, 4, 5. Okay, he's supposed to have 6, but he has 5, so he has a plus charge. 1, 2, 3, 4, 5, 6, 7. So he has 1 extra electron. Electrons are negative, so he's positive, or so that he's negative. 1, 2, 3, 4, 5, 6, 7. He's supposed to have 6. He has 7. So each one is a -1. I have 3 negatives and 1 positive for a -2. Correct. What is my structure? My structure is a 3-1 trigonal pyramidal, 107 degrees. How about for my last guy, because I forgot, he's still a 4-0. So he's a tetrahedral, 109 degrees. Okay. PO4 minus 3, so phosphorus is going to go in the center, oxygen's going to go around. I'm going to go with 5 plus 4 times 6 plus 3, 24, 29, 32 total electrons. So I'm going to fill out all of these guys with 6 each so that they have full octets at 8. 8, 16, 24, 32. So I am done there. I'm going to bracket and charge. Okay, and then I'm going to figure it out. 1, 2, 3, 4, 5, 6. 6, but there's actually 7. So each oxygen is going to have a -1 charge. And the phosphorus in the center has 1, 2, 3, 4, but it's supposed to have 5. Starts with 5, but only has 4, so he has a +1 charge. 1 positive, 4 negatives gives me a -3. So that justifies my overall charge. What's my shape? Still a 4-0. Tetrahedral, 109 degrees. OCl3. Okay, so right now I know linear, 180 degrees. I also know that we have a negative there. How do I know this is chlorine and not carbon? Because if it was carbon, oxygen, and iodine, then I would not have an ion. I would have a full structure because I could double bond with the oxygen and single bond with the ion. But since this is a negative here, I know that that means this has to be chlorine. Oxygen bonding with chlorine, single bond, fill out the chlorine, 7 valence electrons. How many total am I supposed to have? 6 plus 7 plus 1, 14. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. Brackets in charge. Chlorine's neutral, okay, because he's supposed to have 7 and he has 7. Oxygen has 1 more to make that octet. Overall charge is -1. That makes sense. Hey, NO3, nitrogen in the center, oxygen spread around. Nitrogen is a 5, oxygen is a 6, and there's 1 more electron. 18, 23, 24. Okay, and since I know this is 24, 8, 16, 8, 16, 24. Okay, I know I can just put all of that around as single bonds. Okay. Bracket that, -1. But all my oxygens are going to have a negative charge. But my nitrogen in the center is going to have a 2+ charge because he has, supposed to have 5, but he only has 3 in use. So he's a +2 for the nitrogen. And that leaves me with a -1 charge overall. So brackets and charge and atom charges to justify your overall charge. Make sure you have that on each one. SO2, sulfur in the center, oxygen on the outside. Start with single bonds. Count 16, or 6, plus 6 times 2 is 18. This guy's not an ion, so if you didn't want to count there, that's okay. You don't have to. You can follow each method as long as at the end you check your valence and your octet. Okay, so I know each of these guys wants a double bond, so I'm going to put that in. Sulfur wants 6 total. Oxygen wants 6 total. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My valences agree. 2, 4, 6, 8. 2, 4, 6, 8, 10, 2, 4, 6, 8. My octets agree. Sulfur is weird. And he can actually, it's called an expanded octet. He can actually have more bonds than your octet rule. Okay, and that's why I went with the counting electron approach for him, because that does help me figure out 2, 4, 6, 8, 10, 12, 14, 16, 18. Just always go back and double check and see what you have. Okay, he's linear at 180 degrees. I realized I did not do that over here with nitrate. Nitrate's a 3, 0. Trigonal planar at 120 degrees. What else do I need to do with this guy? He is polar because he has a lone pair, no fun bonds, so he's dipole, dipole. HCN. Hey, so I can recognize right here a polyatomic ion of carbon and nitrogen. Okay? And then I'm going to add an extra hydrogen over there, and I'm going to add it over to this side. 4 bonds total. Nitrogen 1, 2, 3, 4, 5. Okay. And I can use my bond approach here as well. 1 plus 4 plus 5 is 10. 2, 4, 6, 8, 10. So that also justifies my valence and octet. Just always go back, or else you're going to end up forgetting that pair around nitrogen and your whole structure is wrong. I am linear and 180 degrees because I have no lone pairs on carbon, but I am polar because nitrogen and hydrogen are different outer elements. No fun bonds because the hydrogen's not with the nitrogen, so it's dipole, dipole. PF2, phosphorus and fluorines. I'm going to fill in my 6 extra electrons on fluorine and the 1 in the bond for 7. Now let's see how many total I need. 5 plus 7 times 2 plus 1 is 20 electrons total. I'm using 8 on each side for 16, 17, 18, 19, 20. Fluorine only does a single bond, so that's why I have him on phosphorus. Plus 2, 4, 6, 8. 2, 4, 6, 8. It meets my octet. I'm going to bracket in charge. Don't need to do polarity, but I do need to do vsepr. 2, 2, bent, 105 degrees. And charges, 2, 4, 6, 7. Fluorines have a 0. And this phosphorus here, 1, 2, 3, 4, 5, 6. He has an added electron to give you your negative.